So let me show you how I like to implement servers and events in TypeScript. So for this, I created this demo to-do application. As we can see, we're getting some keep alive events in both clients. But if I come here and type do the dishes, as you can see, both clients get the same event. So this one right here, and we update the cache accordingly. And this works for all type of actions. So if I delete this, it is reflected in the other client. And if I create this and then mark it in the other client, then again, it's reflected here. So everything is perfectly synchronized via this channel. And we have all of the retries and everything to ensure that the client is connected at all times. So let's jump right into the code. Now, before anything, we'll be using Effect for this. It is an incredibly powerful and type-safe library that if you're not using it, then what are you doing? I have a ton of videos on Effect on my channel, so make sure to check them out. So, first of all, what I did was create an HTTP API group using the SSE identifier. And then here we just have one get endpoint, which is at the root of it. So just /SSE. And this is going to open the connection with the client. But here's one challenge. You need to clean up connections. So let's say a client opened the connection, then you start notifying that connection with events, but then the client closed the connection. What can we do in that case? Well, we would need to run a cleanup, and that cleanup is going to remove the connection from our internal map. That way we wouldn't be housing inactive connections, because with time you can imagine how many total connections you might store in memory. It could easily become 1 million, and every time you push an event, you're pushing events to an arbitrary number of inactive and active connections. Now, the plus of using Effect is that the HTTP API will listen to that event. So when the client closes the connection, it is going to interrupt this effect right here. It is going to interrupt the fiber of the handler. That means that we can run cleanup with finalizers. So let's try it out. So let's say effect.gen, and then here we're going to add a finalizer, which is going to bind the scope to that of the handler. So when it is interrupted, the scope will be closed, and so this finalizer will be executed. And we're going to run or call effect.never, which means that it is going to be running indefinitely. That way, the only way to stop this right here is by interrupting this fiber. So now if I run the server and then do a get request to localhost and then SSE, and then come back, you'll see no logs. And then if I interrupt that here, you will see that the finalizer was executed. And we can test this even further by doing a effect.repeat, and then we can say log info. And then here we can say server sent event, and then do a fixed schedule of 1 second, and so this will run infinitely. And then if I come back here and make the request, you'll see that we get these periodic logs. And then if I cancel the request, you'll see that the finalizer was executed. So Effect is going to guarantee that all of the finalizers of this handler will be executed. And so you can now translate this over to a long-running open connection like a server sent event, where we can do the cleanup there. So now let's try opening this event stream. So what I'm going to do is create a keep alive stream. So keep alive stream is equal to, and we're going to import stream from Effect, and we're going to repeat this with just a keep alive. And then here we can say do this every 5 seconds or 3 seconds. And now we can come here and say return HTTP server response, and we can say stream, and then we can pass in the body stream. which in this case will just be the keep alive stream, but here we're going to be merging the streams, and then we can pipe this through and we can map this through, and then we can encode this. So we can say const text encoder, new text encoder, and just encode each line. And I believe we need to say line and then 2 new lines. And with this, we can now say body stream. And we need to add the content type, which is of text event stream, and then the headers. So we have content type, same thing, just to make sure they should set this header for us, and then cache control, no cache, and then axle buffering, and then the connection is going to be keep alive. And that's it. Now, what the server is going to do is periodically, every 3 seconds, push the keep alive event to the client. Now, before we can test this, we need to change the type of the handler. We need to make this a raw handler. Otherwise, it is going to use the schema that we defined in the contract to decode the response. And if I save this, then make a request, as you can see, we're getting the periodic keep alive events. So great, this means that we're ready to start sending events. A quick side note, I would recommend using the node runtime. I was using the bond runtime, but for some reason it was timing out the stream. Not sure why, could have been a misconfiguration from my end, but node is way more stable anyway. Okay, great. Let's now take a look at how we can actually send notifications to users. So for this, first and foremost, what I recommend doing is creating a service. In my case, I created a service called SSE Manager. Now this is twofold. One, so you can easily test it, mock it, whatever you want. And two, so that you can use it anywhere you want. So if you have a to-do service or a chat service, well, all you need to do is yield the service and consume it, and that's it. So, in my case, what I did was keep a top-level connections ref, which simply holds a mutable hash map, where the keys are user IDs and the value is the array of the active connections. That way, when we need to push an event to a particular user, we simply iterate over each active connection, and that's it. So for this, I exposed 3 very basic methods. The first one is register connection. So we take in the connection ID, which would be a UID. Then we take in a queue, and this is very important. And then we take in the user ID. And here, all we do is call ref.update, and then simply modify at the user ID. And then we append the active connection to the existing connections. And if there are no active connections, so this is the first connection that we're creating for this user, then we initialize it with this non-empty array. We then have this unregistered connection. So we take in the connection ID that we want to unregister and for what particular user. So here we simply go over in the hash map, retrieve all of the connections for this user, and then find the one that we want to unregister. Now, if it doesn't exist, then we do not do anything. So we just return an effect.void and then the map as is. Now, if you have no idea why we're returning a tuple here, or rather why ref.modify expects you to return a tuple, then make sure to check out my video on refs. I go over ref, synchronize ref, and subscription ref. But in short, you must return A and B, where A, this one, is what modify will ultimately succeed with, and B is the new state for the reference. So this is a way for you to be able to derive and return something different, or in our case, be able to return an effect here, where if there is a connection to remove, then we simply return q.shutdown, and the new state is simply removing the connection ID. And that's it. And then we simply do an effect.flatten. Why? Because ref.modify returns an effect, And on top of that, A, which would be the first element in the tuple, is an effect. So we're getting nested effects. So we need to call effect.flatten. And then we have notify user. So we get the connections for a user if there are connections, which should actually be or .value.length is equal to 0. So if there are no connections, we do not do anything. If there is at least one connection, then we encode the event. So we're using schema for this, where it must be serializable to JSON. If it's not serializable to JSON, or well, the encoding process failed for whatever reason, then this is going to cause a defect. Now, assuming you have telemetry and whatnot, then this should be super easy to trace back. But assuming you validate at your system boundaries and you leverage the compiler, then this should hopefully never fail, with the only exception being that some property is not serializable to JSON. And then here we go over each one and we simply offer to the queue. And to which queue? Well, to the queue that we create per each connection. So this one right here. And that's why it's a queue of type string. Anyway, with this, what we can now do is in the controller consume the SSE manager. And so here we yield the current user, assuming you have middleware set up. And then we create the queue for this particular connection. And then we simply say register connection. We pass in all of the necessary info and we add a finalizer. So unregister connection. And as we learned, when an effect is interrupted, then the finalizers are called. Though this depends on where you created the scope, but behind the scenes, this handle right here will assign a scope automatically for you. So now we can try this out. So for this, I created a notify endpoint. As we can see here, that all it's going to do is notify the user, sending a test event. Now for this, I have this auth middleware with just static data. As we can see, a made up user, so that we can try it out. And here in the contract, we have this post endpoint. So path/notify. So if I come here and connect to the stream, as we can see, we get the keep alives. But now, if I come here and do a post request, we should get the event here. And as we can see, we get message hello and tag test event. And if we do this multiple times, as we can see, we get the 3 events. So great, with this, we can now hook up the client and use the same schema, which is this one right here, to decode the payload. Okay, perfect. So now let's take a look at the front-end integration. So for this, I have a Vite application with React, and it's just your usual to-do application. So notice how in both clients we're getting the keep alive events. Now if I come here and add a task, as we can see, both of them will get the event. We update the local cache and whatnot, and everything is properly synchronized. So now if I check this, it is reflected on the other client, and if I delete this, then we have no to-dos anymore. So how did I achieve this? Well, for this, I have a namespace, which is called SSE queries. In the front end, I like to keep all of the data access computations within a namespace so that I can export types and the runtime values under a single entity. But anyway, here I have this SSE connector, which is just a component for the SSE side effect, and that is establishing a connection and listening to the events. So this component just returns null, and that's it. Now here I have the use effect, and here we establish the connection using this handler. And here we use the API client. Now for this, I'm using an unsafe client. So if you have used the platform module from Effect, you know that you can take the contract, in my case, the domain API. And here we can set base URL, transform client function, but ultimately this will give us a nice type safe client and runtime safe client as well, as opposed to say something like the TRPC client, where we can say client dot and then todos and then dot get, and these will internally use the schema from the contract to decode the response. That's why we get a parse error here. But there's one fundamental problem with this, and that is it uses the schema to validate the response. And I noticed that when expecting a stream, it wouldn't work. Now you can optionally pass in an option. So here we can say with response true, and this will return to you a tuple where the first element is what the procedure succeeds with and then the raw response. But this didn't work either. It would simply get stuck. So for this, what I did was basically fork this HTTP API client, and I created my own unsafe HTTP API client, where all I did was remove from the resolver the validation and the decoding process. So instead, with this client, if I say unsafe client dot todos and then get, and I just noticed that this doesn't make sense, but ignore this, we get the response. As we can see, we do not get an array of to-dos. And so with this, I get the type safety of actually hitting an existing endpoint and not losing that developer experience. And so we can now access the stream directly. So with this, we decode the text, we split the lines, we then filter out empty lines, and here we use stream.share. So it takes the source stream, so all of this right here, and creates a shared stream. So it allows multiple downstream consumers, so in this case the keep alive stream and the data stream, to subscribe to and consume the same underlying stream concurrently. Now the reason we do this is because, if I'm not mistaken, a readable stream, so what this is doing behind the scenes, can only be consumed once. So we must use stream.share to broadcast. Anyway, with this, we then create the keep alive stream. And this one, well, we filter out this particular event and then we apply a timeout. And this is basically all this is doing. So if it has not received a keep alive event in 8 seconds, then it is going to fail the whole computation. That way we can apply a retry and not lose the connection. And then we have the data stream. So same thing, we filter out the type of event and then we decode either. So notice how we're using the same schema as the one in the server, but instead of encoding, we simply decode. And then here we filter out the invalid events. So we log a warning just in case, so we can see why it failed to parse that specific event, and we keep the succeeding ones, because we can see a union of all of the events. And same thing, we share it. Why? Because we're going to have a lot of consumers. Imagine 20 different services in your application, then it makes sense to share all of these computation right here, instead of having each one do the same thing over and over again. And we merge the stream, and in my case, I like to keep them, as I said, in namespaces, where the namespace would export a stream function, which we're going to see in a moment. And we do a stream.runDrain. So discard the output, let's just worry about the side effect. And notice how here we have an effect.fail. And the reason I do this is because if the server were for some reason to gracefully close the connection or even the client, then we can apply a retry and again establish a connection. This is because I want the connection to be open indefinitely. There are no conditions as to why a user shouldn't try to establish a connection, but this obviously depends on your requirements. And then here we catch all cause to catch those defects, and we log the error, and then we refail so that again, this retry policy can do something and it won't just kill the whole connection for the rest of the session. And here I use a monitor latch. So this ensures that if a user does not have an internet connection, then it will not run any of this. So it will wait until the latch is open. So a latch is open when there is an internet connection and it's closed when there isn't. And that's it. And we run the fiber, and in the cleanup function, we interrupt the fiber. And then we use it here in my global providers component. As we can see here, SSE queries.SSE connector. Now, as for the actual consumption of the data, here into those queries, I have this stream where we filter out the events by using this utility, which I created here in this namespace, where it simply checks against events and looks for those pertaining to the Todos namespace. And then here we tap the event and we match on it. And I'm using the effect match module so that we can reduce some of the boilerplate by using match.tag. And that's pretty much it. And here I have all of the logic, so I use an optimistic ID to prevent dupes. So a race condition from the SSE versus the result of a mutation. And here for deleted to do, same thing, filter out the cache entry. Now, if you want to look at the whole code, you can find the repository in the description. But this is how I would implement server-sent events, all using effect, since it comes with huge benefits and makes your code super simple and declarative and readable, as opposed to, well, doing it on your own. Anyway, this wraps up the video. If you want to see more content like this, make sure to subscribe. I'll see you in the next one. See ya.